Namaskaram everyone. Welcome back to the 58th episode of Master Unreal series. And in this episode, I'm going to show you how you can create the item instance for your inventory. So all the items that you see in your inventory, we are going to work on that class, which can be used for that purpose. So if you haven't watched the latest episode of inventory system, then I highly recommend you do that because that is where the foundation of this entire thing lies. And from now onwards, things will get more modular and easy to implement. So without wasting any time, let's get started. So in the last two episodes, I showed you how you can create fragments that you can use to define characteristics and basic attributes of your items. And then in the next episode, I showed you how you can create a definition class as a base and then derive all your items from it and use fragments to define the nature and the static information your item holds. Now, in this particular episode, we are going to focus on the instance. Instance are the actual items that are placed in your inventory. These three rifle ammunitions are of class rifle ammo definition, and from that definition you created three instances of it in your inventory. So now you hold three rifle packets with different number of bullets in them. Another thing that you need to keep in mind that it is going to hold your mutable data. So for example, if this is a gun, it will upgrade. So whatever upgrades you will do, it will be stored in the instance. Okay, so let's start the phase 2 where we will deal with the instance. Assuming that you have created the items from the base class that we made in the last episodes with the help of these fragments, and I hope you might have created your own fragments as well. So we will continue. Let's focus on the instance. In the base class, you created different child classes which basically represent different items. Okay, but in the instance, you will just have one class, no child classes. This particular class can hold your mutable data, doesn't matter what the characteristic of your item is. For example, if I focus on a handgun, then a handgun will have three fragments. Let's say first is my gun. That means this gun fragment will give us firepower, reload speed, magazine size that you can upgrade via going to shop or merchant. And guess how you are going to store it? It's going to be stored as a map with the help of gameplay tags. So you are going to create a variable which will be a map and it will store the attribute variable name which is defined in the gameplay tags, and then you will store the values. Now whenever you upgrade, you will come to instance and you will access this map and you will update the firepower or health or for example price. Like for example, if you upgrade your weapon, the price will also increase. Now it cannot be the default price at which you bought the weapon, so the price can be upgraded here in the mutable data. So that is the core of this instance where all the data that can be manipulated, it will be stored here. Okay, so let's create this instance class, and on the way I'll also show you how you can use this very simple instance class to have a control over the memory allocation when you destroy or recreate the items. Okay, so let's get back into the code base. Okay, so we are in our code base now. We created this definition and we were storing fragments in this. That is your static information. Now let's get into the instance. Now hit this play button and start the project. I already have the project build. So I'll open my tools, new C++ class, object, and I will go for inventory item instance. This is the class that is going to serve all your instances in the inventory. And same thing, we want to store it in the inventory folder. So I'll select this folder and I'll create the class. Now, once your class is created, reload the project files and remove this inventory from the path because the header and the C++ file are both in the inventory. So let's fix this common glitch. Great. Now let's focus. As I said in the last two episodes, always decide whether what you are going to define is accessible publicly, or is it private, or is it accessible to your child classes only. So for this, we will say this time private. Private means only this class can access it. Now, what is it that we are trying to keep private? The first thing that we want to keep private is the definition class of the item. Now, why I'm saying this is because if you recall this explanation from the last episode, if I give you the access of this player object, okay, or if I give you the access of this rifle, you will be able to modify any of its detail. If you expose your variable in any way, like by using public or protected, anyone who reads the information can also modify the information. Why I'm saying this is because once you expose the variable, you are also exposing where the variable is stored in your memory. So if I know the place in the memory, then I can also update it, right? That's where the hacking and cheat codes comes into the picture. You are making your variables public and anyone can edit it. Now in this situation, we do not want the definition class to change. So I will say T subclass of U inventory item definition, and the variable name is item definition. Now we need this class, so we will say hashtag include inventory item definition, which is present in the same level in the inventory only. So you can directly write it. Now, why we wrote subclass? Because item definition is a base class and we are not accepting the base class. We are accepting the child classes that you have derived, which means your items like green nerf definition, AWM definition, handgun ammo definition, like that. So the item needs the child class that you have defined, which are your items, to be stored here. Now I told you we will be storing the mutable data in the map. So again, that map will also be private, because if you want to change any values, then you have to call the functions so that you do not put anything unusual or invalid or some kind of 999 number to make things infinite. Okay, so to use the map, we need gameplay tags. So let's include it. Always make sure you include everything before this dot generated. So I'll say include gameplay tag container.h. Okay, once you are done, you can go for t map. Now map of what? So the key will be f gameplay tag, and what will be the value? In this case, it will be a number. So I'll say int 32 and I'll say stat tags. Okay, so whatever numerical values that you want to store will be stored here. Now again, the same thing, if I expose this as a public variable, then you will be able to access every tag in this and you can change value of anything. We do not want that. So what we will do, we will keep this private and we will say if you want to read any tag value, then call a function and provide what tag you are asking for. Just like in banks, they don't let you access the bank vault. They will always provide you a service. Some manager will come to you and they will assist you, and then they will give your things and etc etc. So what we will say, these are my private variables. Next thing I want to do is make some functions that are publicly accessible to do certain operations. So let's say I want to give a function that can increase the value of a gameplay tag. So I'll say void add stat tag stack. And the function will accept two parameters. First of all, tell us what tag value you are trying to increase. So we will ask for f gameplay tag. So you give us the gameplay tag and then you give us the value. So we will say int 32 stack count. Also, let's do capital T because we are following Pascal case, and put the semicolon. So now what it will do, it will add the stack count that you are sending into the stat tag which is present in this variable. That's the agenda, and that's the reason we created this function. It is very important to understand why we are writing every single line. So this one will serve the purpose of adding things. Now, just like this function, we will create another function that will remove the stack count. So we will say remove stat tag stack f gameplay tag tag in 32 stack count. Okay. Now this function will reduce the count. This function will increase the count. Do not do both the things in the same function. So the third thing we want is to get the value of the tag. Let's say you have a hand grenade in your hand and now you go to your inventory and you pick a handgun. So in that case, you would want the tag values of that gun. So for example, we need to know firepower, we need to know magazine size and everything. So we need a function that can retrieve those values from the stat tags. So that is the use case. We will say that we are going to create a function that is going to give us the values of tags that are present inside this. So the values of the tag is a integer. So we will say int32, which is exactly what you have defined here. And then we will say get stat tag stack. Then you will pass us the gameplay tag and we will give you the value, and the value will be integer. Okay, so let's do this first. So these are the functions. Let's implement them in the C++ file. So we will go to inventory item instance dot cpp, which is this one, and I'm going to first implement the add stat tag stack. So I'll say void. Then what is the class name where this function is present? So we'll say u inventory item instance is the class and the method name is this, and it accepts two parameters, that is these two. Okay, now you provide us what you have to do. So before we do anything, we always perform checks. These checks are called edge cases. Edge cases basically means any kind of situation that can block the execution of your function. See, the core goal of this function is to increment the count of the tag. But before we do that, first thing that we have to do is make sure the tag is valid. If it is not valid, then stop. Don't go further. So we will say if the tag that we are receiving is valid, and we will put a not. This simply means if the tag is not valid. So we will say return it. That means we do not want to do anything. Let's go further. What if my stack count is 0 or less than 0? Because the idea of this function is to increment the value, and now you are having two situations. First is you pass 0. That means you do not want to add anything. You are wasting our time. So we will say if stack count is equals to 0, then return. What if it is less than 0? Then also we want to return because you are not calling the right function. So we will say less than equals to 0. So if it is less than equals to 0, stop. Now if these two checks are cleared, that means you are ready to increment. But there is a chance that the tag might not exist. If in case the tag does not exist, we want item instance to create that tag. So we will say stat tags dot find. Okay, so instead of just calling find, we will say find or add. So there is another function. What it will do, it will find the tag in the map, but if it does not exist, it will add it. So if it exists, then also you will get the value. If it does not exist, it will create one and then it will send it to you. So in both the cases, you are going to get a tag value. So I will provide it the tag that we are looking for. Now we have to store this because we have just located the tag. We have not incremented its value. Int 32 value. So we will store it. Okay. And now we will increment it and save it back. Now here's a catch. What is happening? First, you will find the tag. Second, you will increment the value in the variable. Then you will send it back to the map. Now in this process, in the first step, you found the tag. In the second one, you created a new variable just to store the value and increase the count. And in the third step, you are sending the new value into the map again. So this allocation is unnecessary. what you can do is use reference. So what will happen in the reference? You find the tag, it's not going to create a new variable. Instead, it is going to tell you the location of that tag value. Okay, so you asked to find or create the tag. Once the tag is created in the map, you are asking where is it created. I just want to know and I will go there directly and update it. I don't want a new variable just to hold the value for 2 seconds. So what I will say, tag value is equals to tag value plus stack count. This means whatever the tag value was before, just add the stack count. There is another way to write it. I'll put it in comments. Another way is tag value plus equals to stack count. So instead of writing it like this, you can also write it like this. You can put a comment in case you are a newbie and learning C++ with me or on fly. Okay, so two things you did. First, you did not create a new variable just to store the value. Second, you used this fancy operator to add the values. The next function that we want to implement is the remove tag count. Now let's copy this void and then go for it. Let's put the class name and we are good. Okay, first comes the return type, class name, what is the method, what are its parameters. There is another thing you can do. Instead of writing two ifs, you can do if the tag is not valid, or these two symbols represent or. Stack count is less than equals to 0. I do not want to proceed. Okay, so two lines are clubbed into one. So let's do the same thing here again. If tag is not valid or the stack count is less than equals to 0, then you are trying to waste our time, which we are not allowing. Now removing the stack tag count means this should exist, because if this tag does not exist, there is no point of reducing its stack count. So what we will say, just find, do not add. So we will say stat tags dot find. Always write what you are speaking, the gameplay tag. Okay, so let's check. This function returns a pointer. Okay, you see it returns a pointer to the value associated with the specified key, which means it is not going to give the value. Here you were getting an integer value, and instead of getting the value, you said tell me where this value is. Now here it is giving you a pointer which tells you where the value is located. Here you knew where the tag value is stored, and in this case it is not telling you where it is stored. Instead, it is giving you an address that will tell you where it is stored. So I hope you understand this pointer and a reference which I clearly explained in the last episode. So I will say, okay, it is a int 32 type value and it is giving me the pointer, not the value, not the direct address. It is giving me a new address that is going to tell me where that value lives. Just like in the game, you first start your mission and the map tells you where you have to go, and then you go there and then you find your mission. And I will say pointer. Now first thing, is that pointer valid? Because you are giving me address in the memory. See, the pointer is like giving you address where you will go. For example, I have to go to this 3300 to know where my equipment lives, which is rifle. So then here I got rifle address. So this address can be empty. Remember, when you spawn in the game, this equipment is null. That means you have not equipped anything. As soon as you equipped, it changed the address to 3500. So what we are checking? We are checking if this pointer value is still valid. So now again, we have to make sure this pointer exists. So we will say if this pointer does not exist, return right away. That means don't go further. Why I'm saying that is because due to garbage collector or due to any override or due to network delay or some concurrent request, If this pointer became invalid, that means it is gone from the memory, then you will never know where that value is stored. It is like deleting your map out of the game. If the map does not exist, you cannot find your way unless you check every road. I'm talking about when you start the game for the first time, right? And even then, you will not find it. There is a very high possibility. Okay, so this is the same thing. So we'll say this pointer, is it still valid or not? If it's not valid, then just return it. But if it is valid, then we would like to subtract the count. Now, how to use this pointer value to get to this place? Just like we had reference, we actually go for star pointer. This means whatever address this pointer is pointing to, go there, and whatever the value is present, just do your thing. So we are saying whatever the value is stored at this point, you subtract from it. So we will say subtract stack count. Now you can write it just the way you wrote this. You will say go to that place where this pointer is pointing to and subtract. That means minus stack count. As simple as that. Cool. You understood how to use pointer, you understood how to use reference, you understood how to use edge cases, you understood how to do plus and minus like this. That's 3 functions and you learn 3 new things as a newbie. Oh, by the way, just write the variable name. I think I forgot to write that. And now I'm going to do this function. So let's copy this, make sure this variable name is there. So let's paste it and we will put the class name before the method name. And then we will implement. So if tag is not valid, if tag is valid and put a not, then return it. But this time you have to return something, otherwise it is going to give you an error. So we'll say return 0 because your function says you have to return an integer. And here you said return nothing. Void means nothing. So you don't put a value. Okay. And if the tag is valid, then first find that tag, whether it exists or not. This was checking whether your gameplay tag is valid or not. Now we are going to check if the gameplay tag exists or not in this map. So we will do the same thing we did on top. Int 32 star pointer stat tags dot find tag. So we got the pointer. Now we will check if this pointer is not valid, then return 0 again. But if this pointer is valid, then return the value where this pointer is pointing to. So go to that location and then return the value. There is another way to write if or else. See, there are another way to write this thing. If the pointer is not valid, you will return the value. But if it is valid, then you will return this. Okay? Great. So you did your 3 functions. Alright, so let's address the elephant in the room now. If you have a control over object creation, you will also gain control over your memory, right? So there are 2 ways to create the object. One in C++ that is using the new object, and then you will provide the class. For example, in our case, it is inventory item instance. And once the object is created, you will save the details, like for example, what is the item definition, what are the tags, etc. If you are a blueprint lover or coming from the blueprints to C++, you might have observed the construct node. You provided the class and it will ask you the variables that you have exposed for spawn, and then you can provide the values for them. But either way, if you want to save the details, first you have to create the object and then you will be able to update the values, or you can provide it in the constructor as you saw in the previous episode of gameplay attributes, right? So if we go with C++, you have constructors or separate functions that you can call, but they can only be called once you create the object. But let's say, what if your item definition class is not valid? There's a possibility, right? Or there is some data that is not valid. In that case, you will end up wasting the memory because you have created the objects either way, but now the details inside that object is invalid, which means you will not be able to use it. So it's just lying there in the memory. So it is a waste of memory. So we do not want to allow creation of object if the data input is not valid. So what do we do for this? Let's understand the requirement. We want a function that can first validate all the input values that are crucial for the object or which are basically required for the object. Then if those values are okay, we will create the object and then we will put the values. But there is a problem. You cannot. So far, if you are following this series and you are learning along with me and not from other sources, or you do not come from programming background, so far we do not know how to call a function without having its object reference. Let me show you. If I go to my BP player, I have a weapon actor. I want to call its fire function. So if I call the fire function, it will not list because we are calling the fire function for which weapon? We do not know. We do not know its object reference. So for this, we have to first create the object. So let's say I construct the object from class, then I give it a weapon. I call it B weapon, or you can use any derived class, like for example, B rifle. Then you have the object reference and now you can search for fire and it will call the fire because you have provided the target object. If you have saved it in your variables, you will use that variable which is holding the object reference. But the problem is you need object reference. If you are following the series and inventory episodes, especially the episodes from 11 to 21, we created this generic functions library. Now here are a lot of functions which can be called. Like normally, if I go to generic functions, there is a function is area out of bounds. I can just search for it, is area out of bounds, and it appeared. No object is required. So that's what we want to do. So the solution to this problem is using these static methods or functions. You can use them without the object reference. That is the solution. We create a function, we put our logic, and that function we mark it as static. So when you mark something as static, it will be available for you to call without having the object. So we go back to our code and we will write, first of all, static. This means this function is static and I am going to create the object and return it, but only if inputs are valid. So the thing which we are going to return is the inventory item instance object reference, which means a pointer. So what does this mean? We will create the object which will be registered in the memory and we will give a pointer that will point to this value. Because as you know, we cannot carry the big objects everywhere. So we will create in the memory and then we will store its reference in a pointer. So we are going to return a pointer where the object is created in the memory and I will call this function create item instance. Now here I need one thing, that is the item definition. So item definitions class, let's copy this input, paste it here and let's rename the variable. I'll call it input item definition. If this is valid, then we are good. So we will copy this function because we want to implement it. We go to C++ and we paste it here. And it is coming from the inventory item class. So I will paste it here. Great. Now you can implement. So what I will say, if the input item definition class is not valid, then return. Return what? In case of void, you were not returning anything. You were just calling return. In case of integer, you were passing return 0, a 0 value. In case of pointers, you pass null pointer. That means it is not pointing to anything. But if it is a valid class, then we will create the object. So first create the object. So new object and tell the class name. So I will copy the class name and then I'll create the object and it is done. So now you see it is also returning a pointer to this class, which is exactly we are doing here. So let's save this object pointer in a variable and I will call this variable as item instance pointer. Okay, now once you have created the object, now you can save the details because we know it's going to be valid. So item instance pointer, item definition, and the class is input item definition. If this was not valid, then the point of creating this whole object is gone. And then we will return this item instance pointer variable, which is the value. Great. Now let's go back to blueprints. You see there is this outer variable. Now this is very important. No one cares about this when they are learning Unreal Engine, and it is also referencing to self. So that means you do not have to provide the value because it will consider this player itself. What does this mean actually? See, whenever you create or register an object in the memory, someone has to take care of them. Which means, for example, I want to talk about this situation from our game. Let's say if our player character hits something, for example, this door, the mesh will be gone, it will be broken and it will disappear. If you have a player who's carrying weapons, or if there is an enemy who is carrying weapons, if you kill the enemy, the body armor, the weapons it is carrying, everything will be deleted from the game and from the memory. The items are gone from the memory, that's why it disappears in the game as well. So how do they automatically disappear? Because you were just destroying the enemy, you did not destroy its armor or battle axe or anything. So the way to do it is by providing an outer. What does this mean is this particular object is created in this blueprint in this class. So this player owns this object. So if player dies, this object dies too, because outer says self, which means this class. That's how these components are destroyed. For example, if you kill the player, these managers components will be destroyed too. And that is also another reason why people say that do not put your inventory in component or player, because once the player is destroyed, the components are gone too. This is the reason. So someone has to own it so that it can be destroyed automatically by the system and you don't have to delete it manually. So just like in construct object, you also have an outer in the new object. You have to provide it. So what I will do, I will accept it in the input. So whoever is calling this function, they have to provide their reference so that this item is registered under them. So u object star outer. Okay. If we go to instance, you see in the new object, it is clearly asking that u object star. This is the type and variable can be. Variable name is outer. Although you can name whatever you want, I mean the variable, but the type is u object pointer and this is called outer. So we are going to pass this outer here. Now just for testing purpose, we can go to item instance edge and we can mark this function and expose this to blueprint. So I'll say blueprint callable. And I'll go in my third person map and I will hit the live coding. Okay, once the compilation is done, you can go to any class, for example, your player, and now you can search for create item instance. You see the function is listed. You do not need the inventory manager's reference or item instance reference. But let's test again. If I mark this function as blueprint callable, I will not be able to call it without having the object reference. Go back third person and hit the compile again. Okay, let's go back to player and now search for get stat tag. It will not appear because you need the object. Now this item instance is going to give you the object, so you can call it get stat tag stack. You see, because you had the object reference of the inventory item instance. So that's it for this video. I hope you enjoyed it. Do let me know in the comments if you have any suggestions, feedbacks or doubts. And in the next video, we are going to see how you can integrate the instance with the fragments so that if you are creating instance of any item, how the fragments can load their mutable data into your instance. So if you like my work and you want to support me, the Patreon and the Coffee link is in the description and the Discord link is also present along with them. You can find all the assets for free which are used in this entire series. So I'll see you in the next episode. Till then, take care. Bye bye.